Hey, I'm Alex, and today I'm going to give an intro to Erlang. Can you see my slides? Alright, so I would like you to follow along with this demo. There's going to be a lot of code at the end. Please go to the repository I created, which is at github.com/aberke, that's ABERKE, /mlh-hack-day-erlang-intro. Alright, so what is Erlang? Erlang is a functional language. By that I mean as opposed to object-oriented. It's strongly typed, you have to compile the code before you run it, and it's garbage collected. So unlike C, you don't have to worry about allocating and freeing memory. Erlang is both a language and a runtime system. That means when you download Erlang, you're also downloading a virtual machine called Beam that the Erlang language runs on top of. Usually when you hear about Erlang, you hear about concurrency. We'll talk about that later. Alright, I want to show you Beam. Here's my repo that you guys should all be at. Feel free to clone it, and let's open up Beam. Alright, so from the command line, once you download Erlang, you can hit Erl, and we're into the interpreter. On the right, I have my repository, the directory for my repository open. And let's just play with the interpreter for a moment. I can do something like 1 + 1 is 2. I can assign a variable. 1 equals the value of 1. You can see that, that's assigned. So as you can see, each statement ends with a period, and variables have to start with capital letters. What I'm going to do here is I'm going to talk about why you should care about Erlang. Erlang is awesome, and then we're going to do some more coding at the end. Alright, so Erlang was originally developed by Ericsson, and Ericsson is a huge communications and telecom company, mostly in Europe. And they developed Erlang as a proprietary language for their telephony system, but it was later released as open source or free software. So Erlang has a lot of advantages, and one of the big ones you hear about is concurrency. Processes in Erlang are extremely lightweight. You can run millions of them at a time. And that's because processes are not operating system processes, they're not threads, they're these processes that run on top of the Beam virtual machine. And you can pass messages between these processes that are all running concurrently, because each process has this concept of a mailbox, which is really just like a queue that collects messages sent by the other processes. And processes are used for many things. They don't just do work. Sometimes that work can be storing state, and I'll talk more about that later. Another cool thing about Erlang is it can be distributed. So you have all these processes, and they're all running at the same time for the same application, but they can be running on separate machines. Erlang was built with that in mind. Erlang has a special way for different machines to communicate. Erlang is also very fault tolerant. So the work that you want your application to do, it'll be spun up in another process, and you might have a special process that's a supervisor process. And a supervisor will spin up processes as necessary to do the work, and a supervisor can also detect when a process fails. So say a supervisor spins up a new process. The supervisor can then handle cleaning up if the process fails and then start the process again. So Erlang is very unique in that there's this philosophy of let it fail. Let a process fail and let that error propagate so that then the supervisor can hear about it and handle it appropriately. So consider this example. You have the supervisor, you have some work that needs to be done, maybe in a function called do stuff. And so the supervisor spawns a process to do that work. And say this function do stuff calls another function called sings. And for some reason, the sings function fails. Maybe there's bad data, maybe a database was corrupted, or maybe the machine just died, or maybe there was a network outage. Something went wrong, and we don't catch the error. So the error is not caught in sings. Don't catch it there. but then the error propagates up to do stuff. Don't catch the error there either. Let do stuff also fail, and eventually the process will fail, and the supervisor will hear about that failure and then can clean up as necessary and try again. So that's one of the unique coding styles of Erlang. Another advantage of Erlang is hot swapping code, which is really cool. It's not done that much in practice, and I'm not going to talk about it more in depth today because it's a bit more high level. But consider why you would need to do that. Erlang was developed by Ericsson, which was developing a telephony platform. And I mean, consider the phone networks. There are millions of people having conversations at the same time. That means like millions of processes. And say Ericsson needs to upgrade some code. They can't just turn their system off, upgrade the code, and then turn the system back on. That means these millions of people that are having conversations on the phone are going to have their conversations die. That's a terrible experience. So instead, you can hot swap code. Code in Erlang is broken up into modules. Modules are just files. And you can swap in a new module version, and the processes that are currently running that need to use that module will finish running, and when the newly spawned processes will then use the new module. So this is really useful, especially when you're considering the application of telephony, which is phone networks. All right, we're going to go back to looking at some code. One of the strange things about Erlang is that data is immutable. So let's go back into the interpreter. I assigned the value 1 to 1, but what if I did something like 1 equals 1 plus 1? That's an error because 1 is already assigned to something. You can't reassign a variable. And this might seem really annoying, but it has its advantages. Consider the fact that you have all these processes. I don't know if you've ever done threading with Java or another language, but usually you have to deal with locks. But you don't have to deal with locks if no one's mutating data, right? You're not handling the same data. Or if you are handling the same data, you're not going to mutate it. So the pro of data being immutable is you don't have to deal with locks. But you might be wondering, how do you then maintain state, right? Like usually when you program, you have some sort of object in memory that's being updated to maintain the state. So another unique practice in Erlang is, since these processes are so lightweight, you can have a special process just to maintain state, like a state machine. And you can have your supervisor also responsible for making sure that state machine doesn't die, or if it does die, catch the state that it was storing and spin up a new process to continue handling that state. And a lot of times you'll have this process maintaining the state, and then when other processes need to access whatever information is in that object, the state process or the server process responsible for updating that object can pass information as necessary. We'll go into pattern matching later, but Erlang is really fun because thinking functionally is really fun. And when we dive into live coding, we'll get into that more. All right. So let's look at syntax. In my repo, I have a file named demo_syntax. And as you can see, it ends with .erl. Files where you put in code that does real logic end in .erl. And when you compile them, I'll compile right now from the interpreter. A .beam file is generated. .erl files are compiled into .beam files. There's a one-to-one correspondence. You also have .hrl files, and those are analogous to how you would have .h files in C. You can define things there and then include them in other files, like my demo.erl file includes demo.hrl. So syntax. Comments are preceded by a % symbol just as you can see that this line is. Variable names have to start with uppercase letters. You have a type called atoms, and atoms start with lowercase letters. Like, I'm going to assign the variable some atom to the atom. And Booleans are just the very specific atoms, true and false. You also have tuples, like 1 or 2, or you can put anything in your tuple. You have lists, and I'll talk more about these later. And strings are just syntactic sugar for lists of characters. And then you have these things called binaries, which we won't talk about here. So each .erl file, each module is a .erl file. And you have to have a statement at the top of your module file that defines the module. And the name of the module is always the name of the file. So this is the demo syntax module. And any public function, you have to export in an export statement. And so here are all my public functions. So I compiled demo syntax, so now I can use it. So I can do demo syntax and test export. I got the value 1. So when you export a function, you have to say what arity you're exporting as well. And arity refers to the number of arguments that a function takes. Since you can have multiple function names, or a function name with multiple arities, you have to define which arity you're exporting here. So for example, test export, as you can see in my example using it, it takes no arguments, so its arity is 0. So this is what a function definition looks like. This is a function that simply returns the value 1. I assign a variable to 0. I increment that variable, but when I increment that variable, I have to assign it to a new variable, right? Because data is immutable. And then the last statement is just returning that variable. And this period indicates the end of the function. As I said, a period is the end of the statement. When I have statements in my function that aren't ending the function, they end in a comma. It's a lot like English grammar, in my opinion. So here's an example of a private function. As you can see, it's not exported in my export statement. And if I try to call it from the interpreter, I get an error because it's not defined past this module. But I can have another variable, another function name called public function, which I do export in my export statement that calls private function. And so this is an example where this is just a wrapper around the private function. So I could call public. Oops. So I don't know if you guys caught on to the syntax that's happening here, but I have defined this public function. It takes no arguments, and the first and only thing it does is just call another function called private function. So let's go back to talking about arity. So as I said, arity refers to the number of arguments a function accepts. And you can have the same function name with multiple arities. And you can export all, none, or some of them. So here's a function that just has arity 1. It's just the identity function. It returns the value that's passed to it. And here's a function named arity multiple, where I define it with multiple arities. So if I just call demo syntax arity multiple with no arguments, it goes into this function, But if I were to call it with some value, like 1, oh, I don't think I exported that one. Nope. I defined it but didn't export it as a point of you can export some or all of them. All right, well, I'm going to call the one that has arity 2. That just returns the list 1, 2, or it returns the list of the 2 arguments that were passed. So as you can see, if we look at what this function is doing, it takes 2 arguments, value 1 and value 2, and then it calls the same function of arity 1, which is the private function that I wasn't able to call from the interpreter. And the 1 argument it passes is the list of the 2 values that were passed to it. And so, all right, so we then call arity multiple, where some value is that list, and then arity multiple returns that list. One way of documenting your code is providing specs, and I think I'm a little behind schedule, so I'm going to move past that. All right, so let's talk more about coding. So remember how I talked about .hrl files? Here's an example where I'm in demo.rl now in the next module, where I'm able to use that value that I defined in the .hrl file, because it's included here. So I'm going to compile the demo.rl file, and I can call demo, get favorite number, so another cool thing about Erlang is pattern matching. You don't see a lot of if-else statements in Erlang code. Instead, there's a lot more use of pattern matching. So what do I mean by that? You can use patterns to unpack tuples or unpack lists. So for example, I have the tuple some atom and then 1 here. And then I can later unpack it here. You can also use pattern matching to define the same function multiple times, but that function head is only executed if the pattern matches. So as you can see, I have this function named pattern matching function clause with arity 1 defined twice. But the first definition is only going to match when the passed item, the passed parameter, is a tuple of 2, a 2-item tuple. And the second one is going to match when I have a 3-item tuple. And if I pass a parameter that is neither a 2-item or a 3-item tuple, I'm going to get an error because there wasn't a definition for that. All right, so I'm going to pass a 2-item tuple. And now I'm going to pass a 3-item tuple. In the first example, they're very different functions. One just passes the second item of the tuple back, and the second one passes back a list. If I try to call it with something else, like some other value, like 1, that's an error. It didn't match any of the function clauses. So one thing to notice syntactically here is that when I define a function twice, right? I have 2 function definitions, one for the 2-item tuple and the 3-item tuple. Only the last definition ends with a period. All the other ones have to end with semicolons because you're not done defining the function. So let's talk about lists. So what is a list in terms of the data structure? A list is really just the concatenation of nodes. It's really just a concatenation of the node you're looking at, that first node, and then the rest. And the rest will always be another list. You just have a node that points to another list. And the syntax around Erlang lists really speak to that data structure and how expensive it can be to traverse that data structure because you have to look at each specific item. So 2 empty brackets, that's the syntax for an empty list. And other than that, the syntax for a list is the first node that you're looking at, which is the head of the list, and then bar, and then the tail, which is another list. So you can represent the same list in multiple ways. You can pick out the individual items. So I have this list 2, 1, 0. Or I could also represent it as the head of the list, which is 2, and then bar the rest of the list, which is just another list of 1 and then 0. And the definition is recursive. So then this list 1, 0 could be broken down further into the syntax of the list 1 as the head, and then another list of just the item 0, which could be broken down further. How? There you go. All right, so let's do something with lists. Let's write a function that makes a list of positive integers up to a digit that was passed as the argument. So for example, I want the list of items up to 5. And there I go. So let's look at what this does. Let's really get to you thinking about recursion, and the cool thing about Erlang is you really got to think in recursion rather than iteration. All right, so in recursion, you always have the base, right? The base situation of when does this recursive function stop? And for our example, it's 0. When you encounter the digit 0, you're done, right? You don't want to go any further. Right, like when I pass in 5, I want the list 5, 4, 3, 2, 1. So here, that means I'm going to return the empty list, right? Because the end of a list is just the empty list. There's no more to point to. That last node doesn't have any other more nodes to point to. It's just pointing to the empty list. And this is an example of pattern matching, right? So I'm pattern matching on the value of the digit being 0. And otherwise, it could be any digit. So here's the function clause that matches on anything else. And what does this function do? It returns a list where the head of the list is the digit that was passed, and then the rest of the list is a recursive call to the function again. So let's go through this if I had passed in 1, right? It should just return 1 item 1. So digit, we get integers list 1. And what this returns is the list 1, right? And then we're going to call integers list with 0. And then we're going to hit the first function clause, which is just going to return the empty list. So then what we end up with is 1, which is the same as just the list with 1 item in it being 1. So you guys are list pros now, right? So we can do something a little more interesting. Let's write a function that doubles each of the items in a list. So this is really just a mapping function where I want to map each of the items, which are going to be integers, in my list to double that value. So if I pass in, there you go. So I have the base of the recursive statement which is when I got to the end of the list, I'm done. I just want to return an empty list. And otherwise, I have a head and a tail of my list that hits the double function as an argument. And I only care about manipulating one item in the list at once, and that one item being the head of the list. So what do? I return a list where it's the same list that I received, except I'm doubling the head, and then saying, okay, continue doing this by going on to the rest of the list. So in terms of if I did a smaller example, which is the list 1, 2, let's look into how we're going into this function. Well, this isn't the empty list, so we pass this function definition, or function clause. So we go into the second function clause, where the head is the value 2, right? Because what hit here is 1, 2. So value is 1, and 2, or tail, is the list with 2 in it. And what we pass back is that value times 2. And then we call the function again with just that list. So the list with just the item 2 hits the function. It doesn't match the first function clause. It matches the second function clause, where the value is 2 and the tail is the empty list. And so we return 4, and then we call double on the empty list. This time we do hit the first function clause, and just the empty list is returned. So what have we created here? This value, or this empty list, replaces this, and this list replaces this. And that's exactly the list we entered it, because that's equivalent to the list 2, 4. All right, you guys should really get it now. How am I doing time-wise? I'm running low on time, so I'm just gonna put the statement out there that in practice, for commonly used functions like mapping, we use the OTP library that Erlang is generally downloaded with. Using this library makes code a lot more readable, and it's common practice. So that function double we wrote, we could rewrite it using the OTP library by calling the map function on the list map function. I think I'm out of time. I hope you guys will look at this further, play around with it, download Erlang, call it from my modules from the interpreter, and if you want some more resources, there's some great ones out there. The creator of Erlang, Joe Armstrong, wrote a really awesome, also pretty humorous book for a getting started guide. He's creative Erlang, and he wrote a really funny book that's really well done. And then there's Learn You Some Erlang, and both of these are free resources on the internet, or you could buy them if you wanted. Thank you.